The ability to be able to quickly and efficiently create your software and hardware components for a project can be a huge advantage for any engineer. Let me show you how easy they can be. As you can see, here's the 1516 controller, the AT10 MPIO, the distributed AT10 SP, and a comfort panel, all of which is on Profinet. And this is the system we want to build up. First step is we come over to our portal software and let's create a new project. Let's give it a name of Getting Started. Click Enter. So now the portal is actually creating a project container in order for us to put all the hardware and software components into. What I would like to do now is configure device, add new device, choose controllers, and let's go down to the S7 1500 unspecified CPU, click Add. So now it's adding a hardware container to the actual project container. That way we can actually start adding hardware and software components to it. As you can see now, the project view is now open. What we have here on the left-hand side is the project tree structure and the detailed view of the project tree structure. The property windows down here at the bottom. Here in the middle, we actually have the device, network, and topology view. This is where we get the photorealistic views of the products. And over here on the right-hand side, we actually have the task card. Well, right now with the device view open, you see we have this little pop-up box right here and a little button called Detect. Let's hit that button. We get another dialog box, and the system's going to go out and try to physically scan and find this actual hardware set. Once he has, and you see that he has found the CPU, we can actually click on the flash LEDs and make certain this is the correct one, and it is. Let's uncheck that and click Detect again. Now at this point, the software is going to go out and try to find all the actual correct part numbers of this local rack, and he's going to actually bring this back into the project. That way we can start programming immediately. If I actually want to change an attribute of this local rack, let me give focus to one of the cards, right click and choose Properties. Channel 6, that's fine, it's an analog. Let's choose Overflow on the diagnostics, and let's change the measurement values to a 1 to 5 volt. Alright, so that's the device view. Let's go to the network view. At this point you can see I can have multiple hardware components here, and let's use the actual hardware catalog to actually choose the AT10 SP remote rack. Right now, let's actually go down to the actual hardware catalog and the distributed I/O AT10 SP, interface modules, Profinet, and here's the correct one. Just give focus to it, and let's drag and drop it up here to the network view. Now, I want to actually give complete focus to it. Let's double click on it. Now I have the device view of it and a photorealistic view of him as well. If I want to start adding cards to him, as long as I have the filter box checked, only the potential cards that go on that local rack are available to me. So let's go to the DI cards, 16 point, give focus to the first one. Now you see the blue highlighted slots. I can actually double click on one of these to add. I can also give focus to it and drag and drop it in. Either which way, it's no problem. Let's actually choose a DO 16 point card as well. Double click on that. Let's choose an analog input. It happens to be this one. Let's drag and drop him in. And last but not least, an analog output. Let's drag him in. We also have to add a server module in order to actually close out this rack. And if I want to change an attribute of this one, you see here I have this white terminal strip. Let's give focus to that particular card, choose Properties, and let's actually choose Enable New Potential Group. Now you see it actually changes the photorealistic view actually in the portal software, and it looks identical to this rack. Let's go back to the network view. Let's use mouse over technology, and if I just mouse over the interface and it highlights, now you can actually do something with it. Let's drag and drop a network connection over to our main CPU and let go. At this point, it's going to automatically create the physical and logical connections, including auto-assign the IP address to that rack. If I give focus to them, choose Properties again. Let's say I don't want to use the auto-assign IP address. I want to change it to 3. Fine, I've done that. At this point, let me give focus to the main CPU, click on the download arrow button. Dialog box is going to pull up, try to find this actual CPU at this point. Now that it has, I can click on load, and it's going to compile the fact that I've made all these additions in the hardware section. If he agrees, he does, click on load. Now he's going to load this configuration down to our actual CPU. Click Start All and click Finished. So now I have a fully functional hardware set. And for instance, if I come over here to these sliders, I move this one up, you see that I'm actually getting some red LEDs on this particular system right now. If I want to investigate what's going on, let's give focus to the main CPU, click Go Online. The way you'll know that is you get the orange bars across the top. And as you can see, we do have a green check mark here and a red wrench here. Let's give complete focus to the actual main CPU. Once he brings in focus, you see we have a red wrench with the analog card. Let's double click on him. And at this point, we can actually click on Channel Diagnostics, and we clearly see that Channel 6 has a high limit exceeded. That's correct. The new system diagnostics for the 1500 TIA portal are actually at the firmware level. So that means as long as you check the box, you automatically get the diagnostics and not one line of code is required. Let's solve our problem. As you can see here, very soon now we get all green check marks, everything's fine. Let's actually go offline real quick. So how about programming? Let me show you some of the innovations there. Let's go to the CPU, let's go down to Program Blocks, let's go to the main OB. At this point I can still use drag and drop technology. Let's go drag a normally open contact, a normally closed, and a coil. And let's build a cylinder circuit, so let's go grab another normally open. And when I mouse over for a connection, you can see the moment it highlights in green, I can drag and drop it anywhere I want to on this line of code. So how about the tags? Let's actually start typing some in. Let's do a start, motor, stop, and motor again. At this point, I like to actually tie this to our actual hardware set. So let me actually do a split screen. Let's give focus to our actual hardware. And let's zoom in. You can see our DO and DI cards here. All I need to do is go grab the start, drag and drop it over, and drop it in place. Let's go grab the stop, drag and drop that in place, and our actual motor coil. So now our code is complete. How about visualization? First thing I like to do though is uncheck the split screen. Let's add a new device, choose HMI, comfort panel, 12-inch. Let's choose a TP1200 Comfort, click OK. So now we're going to get a wizard for the screen architecture of this particular HMI. The first thing it wants us to choose is a connection to a controller. We're going to use a non-connection, click on Next. At this point we have the header, date time, logo, and screen resolution. We're going to use the defaults. Same thing for alarms, let's use the defaults here as well. I do already have a screen architecture with trend, views, diagnostics, and alarms. I'm going to use that current architecture I've already built in. This way, every single time I have a new one, I have the exact same screen architecture for my control screens. Click on Next. System screens, use the defaults. And as you can see here on the left, right, and bottom, I can actually set up the buttons to be anywhere I want to. I'm going to leave them on the left side. Click on Finished. At this point, he's going to have a photorealistic view of the HMI directly in the portal environment. Here it is. Let me go to the network view though. Choose network view. And as you can see, here's all of our hardware components, the I/O, the controller, and the HMI. However, the HMI and controller are not connected. Let's go back to our programming code and let's split screen this with the actual HMI. Let me go grab this bit field and drag and drop it over to the HMI. Now you see we have some alignment bars. That way you can use this like you would in PowerPoint and get it aligned the way you want to with buttons and icons. Let me resize, refit. If I want to change an attribute of this, I just right-click, choose Properties. Let's move it to the center and change the actual size of this text to 23. Click OK. At this point, if I go back to the network view, and if I click on this little button right here, Show Address Labels, the portal's so smart that the moment I pass a bit field from the controller to the HMI, it auto-creates the network connections, physical connections, and even auto-enumerates the IP address. That way you don't have to. Okay, so at this point, what I would like to do is give focus to the main CPU and click on the download arrow button. He's going to compile the fact I've made these changes to the code and the connection to the HMI. Let's click on load. Now he's loading to our controller. Start all, click on finished. At this point, what I like to do is a virtualization of this panel. I have the ability to virtualize any panel in our architecture. That way I can prove it out in a system test to make certain it works the way I want to before I buy the panel. Let's give focus to the HMI. Let's click on Start Virtualization. He's going to make a connection to the actual controller at this point. It has established one. So I should be able to come over here and actually click on our control code. And as you can see on the virtualized panel, it is gone high. It's gone from a 0 to a 1. I was able to build this entire system up in just a matter of minutes. Now that's engineering efficiency.